Hi, ho students, Mr. Kaczynski with you. We're going to calculate correlation coefficients. We'll do this twice. It's a lot of button pushing on a calculator. Okay, so we got these two sets of data. We're going to see how closely they correlate, maybe how closely they relate to each other. So let's put the data in the calculator. We hit the stat button and then edit. And then we'll put this list of lunch break times in our L1 list. All right, and then we'll put these bicycles in the second list. All right, and this isn't necessary to do this, but I'm going to go ahead and graph it as well. I'm going to make a scatter plot. So there's the 5 employees. You only see 4 dots because 2 of them are the same. They're on top of each other. And that does not look like a very close correlation between length of lunch break and number of bicycles sold here. So I think this is going to be a low correlation coefficient. Second quit. Let's go back into stat, calculate. Option number 4 is linear regression. And when I run this program, it's going to give me a slope and a y-intercept of a line of best fit through that scatter plot. So let me show you what that looks like. I'll go to y equals vars. Again, not necessary to be able to do this, but give you a feel of why we're doing this. Vars, so that was vars, stats 5, and then equations, regression equations. Sorry, I went kind of fast there. So let's graph that. And yeah, I would have thought the line would be something like this, but the calculator's saying the line's there. Again, very low correlation coefficient. What we need to do to get our R value to show up is go second, 0, that's the catalog, and we want to turn diagnostics on. So I'm going to jump to the D's. I'll press this button over here to jump down to the D's. You can scroll all the way down, but it takes forever. Turn diagnostics on. All you got to do is hit enter and it says done. And now we'll go back stat, calculate linear regression again, and not only are we going to get the slope and the y-intercept, but we're going to get this R value. Okay, so it's going to say R equals negative 0.432 when we round to the nearest thousandth. And that's a very low correlation coefficient. And that's why this data is very spread out from the line. That's what that's measuring. Let's do this one more time. It's quick and easy. Now we've got instruments versus minutes. Let's go back in this edit a list. So I'm going to go to the top of this, clear this list off, enter in the instruments 5, 19, 20, 31, and 50. And then I'll go to the top of this list, clear it off, put in the minutes. So 6, 3, 2, 7, 11. Let's look and see what that scatter plot looks like. Okay, now this I think is more of a straight line there, so I think we're going to get a higher correlation coefficient. Let's go back to our main screen, go second, calc, linear regression. Once you turn on diagnostics, they stay on until you reset your calculator. It's slightly higher, but 0.7 is not that high of a correlation coefficient. 1.0 being the highest, negative 1.0 also being the highest. So 0.709. A little bit more correlation to this one. If I go back and put a line of best fit through it, vars, statistics, equations, regression equation, we'll see this line fits the data pretty well, but we got all these outliers, which is causing the correlation coefficient to go down. To get a correlation coefficient that's very high, all the points would be really, really close to the line. So that's how you do correlation coefficients. Stat, calc, option number 4. Run it, but you got to have diagnostics turned on. And you can do that from the catalog. Good luck.